Good evening, sir.
Hey, what's up?
Nothing much, sir. I'm here.
Nice, nice, nice. You see, I've greeted you well.
Um, Sir, I can't do anything right now because I'm currently on the
Hey, boy. Sure. After we
road.
make sure we plan for me and I say, as on a log on, I'm going to see the question. Sure, Irie.
Probably about the next half hour, sir.
All right, then, no problem. All right, guys. Good afternoon to you. There's a question that is projected. I'm going to ask that you give it a start, please. And I'll come back to you in another 10 minutes, there about 5:30. To see how far it is that you've gotten. So start for me, please.
Sir, can you please reshare? I'm not seeing anything. Yes, I'm seeing it now.
Afternoon, sir.
Hey, Papa, hold on.
There, yeah, no, man. Yes, sir.
Nice. I left your present on the screen. What I want to see now is I will come in and help. This one is not as long and not as difficult as the one that we did the other day. I want to see how far you can go to the question. Go through the question without my involvement. So just give it a start for me. If you're stuck, let me know because I'll have to, undo it. But I want to see, I have about 3 more of these questions to give you, pass it for questions, and then I move into something else. So let's see how much we can get done today, all right?
All right, sir.
Good evening.
Why, you're good evening, dry, Jesus. But good evening, Miss
Evening,
Otterly.
sir. Sorry.
Thank you, please, ma'am. All right.
So we actually lost to this question because if you realize I've been in class for 2 nights because
so I realized.
work. So that's why I haven't been here. But I'm gonna watch the video. I'll have the weekend off and catch up.
Okay. But did I not send something in the WhatsApp group? You saw something in the WhatsApp group?
Yeah, you sent the question for the work that I was looking at that a while ago.
Yeah, man. Can you just use the time and go through that one for me, please?
No problem. Mhm.
All right, cool.
Good evening.
Good evening. All right, this is 5:30, checking in. Are you okay so far?
Yeah, man, try to figure out what you did here.
Okay, no problem. No problem. Continue working. You can talk to me in the chat if you have a problem with something. Hopefully, I can direct it to it. The rest of you, are you okay with this new question that is projected? Or are you still working? Which one?
Sir, still
Still
working.
working.
Okay. Just want to know that I'm right here and I'm here to help.
Sir.
Yeah, what's it?
Them asking for minimum cost. Them asking us to plug in the X and Y values into the formula or to find D
That's the part one?
for part two.
No, you're gonna go through the whole question. So the question, as I was saying last class, the question will always be on something about minimum because you're trying to minimize your loss or something like that. So go through and classify the nature of the critical points first, and then I'll answer your question.
All
Have you
right.
found your critical points?
Yes, sir.
Good. Have you classified them?
No, sir.
All right. So classify meaning you can plug them in now into D, f of x times f of y minus f of xy all squared, and tell me if it's maximum, minimum, or saddle point. Do those, and then I'll come back to you and to answering your question.
All right, sir.
Cool.
All right, sir. Me classify the points.
All right. Now, hold on. Where are the rest of you? Are how far the others reach? Hello?
So I'm going to the further question and the I sent in the group.
Okay. I'm sure the rest of you are hearing me asking the question, and I'm not going to call you up by name. I'm asking how far are the others? Thank you for responding, Asterly and Ottilie and Shamari.
Sorry, sir, wasn't hearing you. I am just starting the question.
Okay. For the final time, how far are the rest of you?
Sir, I'm hearing I'm doing the simultaneous equation part of it.
Mm-hmm.
Don't fully get it yet because I got my laptop back yesterday night. So
Mm-hmm.
I'm just trying to watch your whole video while doing it at the same time.
Mm-hmm.
So yeah, I'm trying to do the simultaneous part of it.
Okay, thank you. All right. Mm-hmm. All right. All right. Shamari,
Yes, sir.
do me a favor. Take a photograph of what it is that you've done, and send me a direct message in WhatsApp of the photos, please.
So, sir, you're
All
gonna
right.
need the photos?
Huh?
You're gonna need ours as well?
Mm-mm. 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 Mm-mm.
Because I just gonna say I'm gonna have to change penny then.
No, man, that's fine. No, it's just that he's finished, and I don't want him to sit and wait. I'm gonna go through with him using a different method. I
Okay.
don't know. Yeah, yeah. What I don't want to do actually is to say, okay, come, let's do the question together. Because I want to give you guys a chance to do it. So I just want him to do that, and then I'll meet with him in the lobby. How far are the rest of you, please? And thanks. How far are the rest of you?
About to start the simultaneous.
Okay, good, good, good. What about the rest?
Sir, temporarily stuck.
You stuck?
Yes, temporarily.
Or temporarily? Where exactly?
Sir, with the simultaneous equation, I don't think I fully understand it. So
No, but hold on though.
Mhm.
This simultaneous equation though, in all honesty, is nothing like the one that we did before. This simultaneous equation is very straightforward. But before, all right, tell me what you got for your equation. What equations do you have?
All right, for CX and CY.
To solve
Uh, I didn't hear, sir.
name the equations that you're solving simultaneously.
Oh, let me see here. So for the first one, I have 4x plus 2y equals 16. And for the next one, our second one, I have 2x plus 6y equal 18.
Very good, Charles. So just do something now.
No, well, to be
Hey,
honest,
you.
I'm just going off of faith, because I don't really know what I'm doing right here now. But all right, I'll try to push on, sir.
So no, hold up. Because let me tell you how many marks you'd have gotten up to that point. Only 7.
Oh, okay.
I'll give you 5 marks because based on what it is that you got there, it suggests that you'll get the 5 marks for the differentials, the partials, and I'll give you 2 marks for the 1 mark each for identifying the correct equations.
Okay.
So, and remember them question I carry 30 marks. 7 out of 30 mark cut it.
True.
So come on, try it. If you really can't move from the single, all right, let me give you a hint. Let me give you a drum start. So what you need to do is decide which of the variables you're going to try to eliminate. If you want to eliminate the x's, multiply equation 2 by 2. If you want to eliminate the y's, multiply equation 1 by 3. And I'll tell you why thereafter. When you see that, you will see exactly what we're talking about. So you first have to decide which of the variables you want to eliminate and then work with it. I can't tell you that every time you get eliminate the xm first or the y them. No, you have to look at it and decide which is which.
Okay, I'll try that, sir. Thanks.
Try that for me, please. But the rest of you, where are you?
So I'm not seeing a screen now.
Yeah, because you just come to class. Where am I? Where am I? Are you seeing it now?
Yes, sir.
Cool. That's what we're doing. The rest of you, where are we? All right, no answer. All right, no problem.
Sir?
Yes, Mikey.
Yes, sir. So we reach the simultaneous equation.
Did you get the same equations like? Hold on. Did you get the same equations like Taj get a while ago? Were you listening to see if?
Sir, I'll get back to you.
All right, then, cool, no problem. Just sitting. I've heard from you. I've heard from you. I've heard from you. Oliver, are you there? Simon, are you there?
Yes, sir.
How far are you?
So I'm in the same place as Taji with the simultaneous.
Okay. Do you have the same equations like he did?
Yes, sir.
Okay. Aston, where are you, honey? Oh, you're at the same place as me, right?
Yes, sir.
Awfully well, you know, hon.
I'm gonna look at this question now that you the new question that you have up. I was going to the question.
that's all right.
I understand. Yeah.
That's all right. All right.
Third question, knowing that we have 2y and 2x's, right? We're gonna have 2 values for each of them.
You don't know yet. Well, I can answer you. You can know. You have linear equations, so you can get only one pair of values.
Okay.
Mhm. All right. Let me tell you where I'm at. I have 3 weeks to complete the syllabus. And I don't want anybody to say, yes, sir, we're doing block scheduling because we got at the time that extra class in on a Friday from 6 to 9. Those 3 hours on a Friday was your makeup time. So we could split the semester in 2. Let me tell you my honest feeling. I want to know how much already on a numerator now, but when I'm not pleased, I will tell you that I'm not pleased. I cannot be teaching a class of calculus 2 students where more than half the class is stuck on simultaneous. Simultaneous is not calculus 2. Simultaneous is not calculus 2. So I'm not pleased. What I'm going to do, I'm going to break and I'm going to go through the simultaneous equations, right? Not all of you, because I got a paper and I marked it and I sent it back. And, you know, I'm pleased with what I saw. But this is going to be the last time we're going to be doing a question and get stuck at the simultaneous. I'm not preparing you to go into the exam to stuck on the question. I'm preparing you to go into the exam and complete the question so you can pick up your 30 marks or your 20 marks or your 25 marks. That's so much a question I could come from. So me now teach you to go joke jam in the exam. Now teach you for going to the exam and answer the question in its entirety. So I want you to pay attention, please. Those of you who are still, well, outside of Shamari, who has completed the question excellently. Yes, Shamari, you can look to see what is happening, but I want the rest of you to give me your undivided. If you have your stove on, turn it off. I need your undivided for about 10 minutes so that I can go through this. This is the last time I'm going to show you how to do the simultaneous. Last time, because I have another question, part of a question to project today. All right, so let's go. So the question says, the annual labor and automated equipment cost in millions of dollars for a company's production of television sets is given by C of XY is equal to 2x squared plus 2xy plus 3y squared minus 16x minus 18y plus 54, where x is the amount per year, spent per year on labor, and y is the amount spent per year on automated equipment, both in millions of dollars. We need to determine how much should be spent on each year to minimize the cost. Once we're doing production, our aim is to minimize the cost. And let me give you a little background on what is happening here. So for example, during COVID, if you recognize some of your cereal boxes reduced in size, I don't know how many of you recognize. Some of your bath soaps reduced in size. No, the content may be the same, but they are reduced. The size of the content is reduced. Why? Because it's called being smart. It don't make sense to put a box that is 10 inches high or 5 inches, well, 10 inches high that only contain 3 inches of cereal. And I'm wasting material there. Better I go and put 5 inches high and it still contain the 3 inches of cereal. So these companies will come out and say to you, say, new packaging, but the same content. Because their customers are going to say, oh, You're selling something for the same price, but you reduce the content. So them come out and say, no, new packaging, but the same content. So what it is that they're doing, so the material that they're making, they're using to package 1 box of cereal, no chances are that material can package 2 boxes of material. So what the companies are doing is trying to find a way to minimize their production cost. In the United States of America, I love Old Navy. I would wear Old Navy t-shirts from today till tomorrow. If I could wear to work, I will wear an Old Navy t-shirt to work. I love Old Navy t-shirts. Old Navy recognizes now that if they manufacture their t-shirts in the United States, they cannot sell their t-shirts for $10 a one or $8 a one because the production cost is going to go up. So Old Navy is trying to minimize their production costs. So what Old Navy does is to go to those countries that are almost a free labor. So them going to Singapore and them go to Uganda and them go to Zimbabwe. So sometimes when you look in your shirts, in your Old Navy shirts, you see made in Ghana, made in this, made in that, because they go where they find cheaper labor. So if for argument's sake, the United States, it will cost them $5. So let's be realistic. If it would cost them, if they're selling for $5, it may cost them $2 to make the shirt, and they're making 150% profit. So if it costs them $2 to manufacture the shirt in the United States, when them go to these other countries, chances are it may cost them 75 cents per shirt. And them say, yeah, look at it. Them say to the government of that country, yo, I am providing work for your people, you know, and them not have to worry about getting their money. It's foreign exchange for you, because when the money come up to you, you are going to convert the money to them and give them. So you are going to get more foreign exchange where you can do more stuff with it. And that's why these companies outsource their product. So when they outsource it now, what Old Navy is trying to do is to see how best they can minimize their production cost. Because if, say, for example, they came to Jamaica and Jamaica is charging them, the US is charging them at $2 to manufacture the shirt. But they come to Jamaica and Jamaica is charging them $1 to manufacture the shirt. They may not want the business here, but if them go to Haiti, where people not have no work, and them can get the shirt manufactured for 25 cents a one. Hello? Jamaica go lose the contract. And they are going to build up a nice little area there so them can get the shirts manufactured there in Haiti, because the companies are looking where it is that they can save so that they can minimize their costs. So that's all that the question is saying. The annual labor cost of the automotive cost, and automotive cost for the production of these items for this television set is in millions of dollars, and it is denoted by this equation. We now need to determine how much should be spent on each to minimize. So we want to minimize. So here goes. Once you have a question of this nature, you must go ahead and think of your partials. You must think of your partials. What are your partials? Your partials are going to be C of X, C of XX, C of Y, C of YY, and C of XY and C of YX. Now, I'm not going to take anything for granted today because teacher is not pretty pleased. So I'm not taking anything for granted. So we're going to see how it is that we do the differential again, the partial differentials. So we're differentiating with respect to X. We're differentiating with respect to X. Because I'm differentiating with respect to X, I'm holding Y constant. So the differential of 2x squared is going to be 4x. And that's why I have the 4x here. When I differentiate 2xy, my y is a constant y because I'm differentiating with respect to x. So I'm going to hold my y constant, and look what I'm doing with the y. I'm putting my y right here. Now I'm going to be differentiating 2x. When I differentiate 2x, I get 2. I itch up the 2 beside the y. So the differential of 2xy with respect to x is simply 2y. Now I'm going to be differentiating 3y squared. But hold on, sir. The differential of 3y squared is going to be 0 because I'm differentiating y with respect to x. Sorry, I'm differentiating x, but my y is going to be a constant. So when I differentiate 3y, I'm going to get 0. 3y squared, I'm going to get 0. Now, when I differentiate negative 16x, because it's an x, when I differentiate negative 16x, I'm going to get just negative 16, which is right here. And again, the differential of negative 18y as well as 54 are going to be constants because I'm differentiating with respect to x. So therefore, those are going to go to 0. So that is going to be my partial derivative, my first order partial derivative with respect to x. Remember, if you get your partials incorrectly, it don't make sense to move on to the question because everything else is going to be wrong. So now we are going to be differentiating to find the second partial derivative with respect to x. So I'm now differentiating xx. So it means in order to differentiate xx, I must differentiate c of x of xy with respect to x again. With respect to x again. So that's why I'm going to calculate c of xx. Let's go. I'm differentiating this with c of xx. It means that my y is a constant. It means that my constant is a constant. So when I differentiate 4x, I'm going to get 4. But every other term in that function is going to go to 0. So c of xx is merely 4. Now, let me pause right there. Are there any questions so far? And I want you to answer me. Are there any questions so far?
No, sir.
No, sir.
No, sir.
Okay, good. So now I'm going to differentiate the function with respect to y. So because I'm differentiating with respect to y, everything in x will be held constant. So my 2x squared is going to be a constant because there is no y there. My 2xy is going to be holding my 2x as a constant because the 2x come in front of it. But sir, why does not hold the x alone? Same difference. Hold the 2x constant. So I'm going to write my 2x right here, and then I'm going to differentiate my y with respect to y. When I differentiate y with respect to y, I get 1. So this 2x down here times 1 is just simply 2x. So the differential of 2xy with respect to y is simply 2x. Let us differentiate now 3y squared. 3y squared then give me 6y. There goes my 6y here. Differentiating negative 16x with respect to y gives me 0 because the negative 16x is going to be considered a constant. When I differentiate negative 18y with respect to y, it gives me negative 18. That's why I have a negative 18 here. And when I differentiate 54, a constant, it's equal to 0. It's equal to 0. Now, having just found c of y of xy, I'm now going to find c of yy of xy. What does that mean, sir? I'm now differentiating c of y, xy, with respect to y again. This is now known as my second order partial derivative. So differentiating c of yy, I am going to get, with respect to y, my 2x is now a 0 because it's a constant. My 6y, when I differentiate my 6y, I'm going to get 6. And when I differentiate my 18, my negative 18, is going to give me 0. So the differential of c of yy, cyy of xy is just simply going to be 6. Let me pause. Are there any questions?
No, sir.
No, sir. No question.
Okay.
No.
So the c of y is my first order partial. The c of yy is known as my second order partial. Now there's a reason I put those two in color, in blue, because it is my first order partial derivatives that I will set equals to 0 to solve simultaneously. It is my first order partial derivatives that I will put together to form my simultaneous solutions. Solution or solutions. The other terms, c of xx, c of yy, c of xy, c of yx, is going to be used to determine the nature of the critical points. Those are going to be used to determine the nature of the critical points. All right? No question? So let us go to the second order cross partial derivative. We're going to go to the second order cross order partial derivatives. So to find c of xy, I'm going to go over to c of x and differentiate that with respect to y. It's called cross order partial for a reason. It means that I'm using x to differentiate with y, with respect to y. And then in another situation, I'm going to use y to differentiate it with respect to x. So let us find C of xy first. C of xy, it means that I'm going to be looking at my C of x, which is this one, and then I'm going to differentiate it with respect to y. Differentiating 4x gives me 0, because that is going to consider a constant. When I differentiate 2y, I'm going to get 2, because I'm differentiating with respect to y. That's why I have my 2 here. And of course, negative 16 is a loadsome constant. The differential of any constant is 0. So my C of xy is going to be equal to 2. Remember now that your C of yx of xy has to have the same value. Let us double check to see if my C of xy is going to give me 2. In order to find C of yx, I'm going to look at the function C of y, which is this, and differentiate it with respect to x. When I differentiate 2x, I'm going to get 2. I write the 2 right here. When I differentiate 6y and negative 18 with respect to x, I get 0, because they are constants. So I recognize now that my C of xy, as is expected, is going to be equal to my C of yx. Am I clear right there? Do you understand what it is that I'm speaking about?
Yes, sir.
Yes, sir.
Yes, sir.
Yes, sir.
4 out of 8. What about the other 4?
Yes, sir.
Yes,
Good.
sir.
Good. 2 more. All right. Don't know if Oliver's audio is working. He's there, but I'm not hearing from him. All right. Astonil, just touch base with him and find out if he's hearing me now, please. Thank you, love. All right. No, yeah, thanks. So let's continue now. So as I explained, there's a reason I placed the ones there in blue, because those are my first order partials. It is my first order partials that I'll be solving simultaneously. My first order that I'll be solving simultaneously. Okay. So just like when we're doing in calculus 1, we're doing first stationary points of single variable functions. What it is that we do, we set the first differential to be equal to 0. Similarly, that's what we're doing here for the multivariable functions. We're going to set our first order partials to be equal to 0. So therefore, it converts this expression to an equation, and it also converts this expression to an equation. Now, how it is that we set up our simultaneous equations? What we do is put our x values lining up under each other, the y values lining up under each other, the equal sign lining up, and then we put equals to whatever it is. So what it is that I'm going to be doing is transposing these two equations. I'm going to transpose these two equations. And in transposing, I'm going to be adding 16 to both sides. So it is that I can get my equation now to be equal to 4x plus 2y equals 16. Similarly, I'm adding 18 to both sides. So I'm going to end up with 2x plus 6y equals 18. Can you agree with this new arranged pair of simultaneous equations?
Yes, sir.
Yes, sir.
All right, good. Now we're going to be solving. I want you to pay attention. I am going to be investigating both variables. If you see the first equation is 4x and 2x. Sorry, 4x and 2x. Yeah, I was correct. If I were to eliminate my x's, it means that my coefficients must be the same. Why, sir? Because when my coefficients are the same, I can subtract. So if my coefficients are the same right there, I can say 4x minus 4x is equal to 0. And then I would have eliminated my x's. But before I do that, I will have to multiply equation 2 by a scalar quantity. A scalar quantity. Visualize this. X is equals to 2. 2x is equals to 4. Is x still equal to 2?
Sir, can you say that one more time, please?
Sir, yeah, repeat that, sir. I don't get it.
If x is equals to 2, what's the value of x?
2, sir.
Good. If I say to you 2x equals 4, what's the value of x?
Sir, 2.
Yes, sir. If I say
2,
to you
sir.
3x equals 6, what's the value of x?
2.
Sir, 2.
If I say 10x equals 20, what's the value of x?
Still 2, sir. Okay.
Very good. So the point I'm making is when I multiply an equation by a scalar quantity, it does not change the value of the function. It does not change the value of the function. When the baker man is baking 12 cookies and using 7 eggs, and if you want to put in an order and say, yo, I want 5 cookies. I don't want 12, I want 5 cookies. The baker man have to scale down his recipe. It is not, when the cookies are baked, once he scales the recipe properly, it will not change the taste of the cookies. Or it shouldn't change the taste of the cookies. So when I multiply an equation by a scalar quantity, it doesn't change the value of the equation. What it does, it gives me a pseudo form, an equation that appears to be bigger. But I'm not changing the value. And I do this because I want it to resemble the coefficient of the variable that I'm eliminating. So if you see on screen, I am multiplying equation 2 by negative 2. But sir, a while ago you said to multiply by 2. Why did you multiply by negative 2? Simply because if I were to multiply by positive 2, it means that I'll subtract one equation from the other. If I multiply by negative 2, I'll add one equation to the other. Because when I add positive 4 to negative 2, one is the inverse of the other, I'm going to get 0. One is the additive inverse. Let me say that, not the multiplicative inverse I'm talking about now. One is the additive inverse of the other. So when I multiply by negative 2, I'm going to write my new equation. My new equation is equation 3. So I'm going to multiply, I'm going to distribute that negative 2. I'm going to distribute my negative 2 over my equation 2. So negative 2 times 2x is going to be negative 4x. Negative 2 times 6y is going to be negative 12y. And negative 2 times 18 is going to be negative 36. I am calling this equation 3. Go ahead.
Sir. And so we could have used the first function to multiply by 2, right?
No, sir. Because if I use the first function to multiply by 2, I'm going to get 8x. You follow what I'm saying? No, you don't see it.
So you're saying that at all times you're supposed to
multiply by the second equation?
Multiply.
Yes, sir.
No. That's why I said, Mikey, at the start of it, you will have to investigate your question. No, hold on. What, Mikey, if I were to eliminate the y's, which equation will I increase? Which equation will I multiply by a scalar quantity? Just Mikey alone. If I wanted to eliminate the y's, what equation will I multiply? Which of the equations will I increase by the scalar quantities? If I were to eliminate the y's, what would I do, Mikey?
All right. So based on what I understand, sir, now when you're doing the elimination, we would minus the first function from the second function, and therefore, I'm not sure if I'm getting it wrong, but all right. So So the 4, I would say the 4 minus the 2, and then the 2 minus the 6. So the 2 minus the 6 would give a negative. So
How does that help
I'm
you
not
though?
sure.
How does that help you? You go to Florida and you pick up some items and they say to you that the items come up to $150 and you go into your wallet and take out 150 Jamaican dollars and give them. How does that help you? Does it help you at all if you pay them in Jamaican dollars?
No, sir.
No, it doesn't. So therefore, you have to do a conversion. Two different something. One is Jamaican dollars, one is US dollar. Watch me. As the method suggests, elimination. As the method suggests, elimination. You are eliminating when it is that you're subtracting, or you're eliminating when it is that you're adding. Those are the only two operations that we're going to perform. The addition or the subtraction. So you got the subtraction part right, you know. But you only subtract when the coefficients are the same. When the coefficients, when the signs are the same. When the signs are different, you must add. Watch the screen. Let me write the question another way. If I multiply equation 2 by 2, it is because I want to eliminate my x's. So 2 times 2 is going to give me 4x. 2 times 2x rather gives me 4x. 2 times 6y is going to give me 12y. Not 12y squared, but 12y. And 2 times 18 is going to give me 36. That is on my equation 3. If you look carefully here, let me erase this red. If you look carefully here, I no longer am interested in this second equation because my second equation is now subsumed into my third equation. My second equation, if you were to plot those two graphs, I don't know what it is that you did in high school. But if you plot these two graphs, equation 2 and 3, it's going to be one equation is going to sit on the other. One equation is going to sit on top of the other. Why, sir? Because they are the same equations. They are the same equations. Watch me now. The sign for that 4x up here, so, and the 4x down here, so, are the same. So I must now subtract one equation. How do I get rid of the 4x? 4x up here, so, and 4x up here. How do I get rid of the 4x, Mikey? I have 4x here and a 4x here. If I add it, would I get?
Minus the 4x, minus 4x and 4x.
Very good. Mikey, therefore, how would I get rid of the 4x on this side?
You divide it by 4.
How do I get rid of the 4x on this side? Watch my screen. How do I get the 4x on this side here? You said I was supposed to minus because this is 4x and 4x. So if I minus 4x from 4x, I get 0, don't it?
Yes, sir.
Very good. Watch me now, Mikey. If I have 4x, positive 4x and negative 4x, how do I get rid of those? By?
Sir, adding?
By adding. When I said 4x minus 4x, Mikey, what do I get?
0, sir.
Every day. Yesterday, today, and tomorrow. So that's why I'm saying to you that when the signs are different, you add. When the signs are the same like
okay,
this
sir.
one,
Yes, sir. I understand.
you subtract. You understand that part now?
Yes, sir.
All right, good. Watch me now. The rest of you, make sure you're still watching me now.
Definitely.
So I'm going to subtract. Before I subtract, though, I must do an investigation of my stuff. You know, like when you go to the supermarket and you try buy sweet potato, you go make sure say you don't have no worm spot. I know you go buy one mango, you go make sure say no fluxy. And if you're like me, you go buy ripe banana, you know, want ripe banana them very ripe because you know go eat all of them one time unless you make a banana pudding or banana bread. So again, look for the bananas that are turned, or you may want yours to be slightly green because you want it to last for a couple of days. Similarly, you have to investigate the equations. So when I look, I am now interested in that 2y and this 12y. And I recognize that 12y is bigger. So I would want to get a positive value. And the 36, similarly, the 36 is bigger than the 16. So it is best for me to say equation 3 minus equation 1. So that I don't have to contend with negative values. Because I don't like negative values, I'm not going to contend with it. Watch me. Starting here, 4x minus 4x is equal to 0. 12y minus 2y equals how much?
Minus 10y.
12y minus 2y equals
10y, sir.
10y, not minus, Arsenio, 10y equal 36 minus 16 equals
20, sir.
20.
20. So I have 10y equals 20. How do I find the value of y?
Sure, divide by
Divide by 10.
Or you can divide.
Not just divide by 10, but divide both sides by 10.
2 by 10.
So y is going to be equals to 2. So guess what has happened here? I get my same y equals 2. Just like here, so. The only thing is that I multiply the equation by a negative number so that I could add as opposed to subtract. So you decide what it is that you want to do. This is up to you. You have chicken, what you feel for? Fried, fricassee, boiled, baked, stew, curry. Your choice. At the end of the day, you're going to have chicken for dinner. All right.
Sir.
Yes, Papa.
That's it.
Sorry, I said, Otterly?
Yes, so basically
Okay.
when you use the negative, when you use the negative figure, when you're using the negative to multiply through, then you add on. If you're using a positive, you would subtract. Okay. Other part, them whenever they get some.
Was there not finished or something?
No, I'm just responding to something in the chat. No, yeah, we're not finished yet.
Sir, I realize what I did wrong, sir.
Who that talk to me? Mikey?
I'm off that.
Oh, so Sherry, you just got my message, right?
Yeah.
All right, cool. But all right, look at that one. You soon see it. All right, watch me now. So having found the value of y to be equal to 2, you're going to substitute y equals 2 into any of the two equations. Matter of fact, any of the three equations. So let me see which one I use. So I use equation 1. So anywhere in equation 1, I see y, I'm going to put 2. So this is 4x plus 2 times 2 equals 16. 4x is equals to 4. 2 times 2 is 4 equals 16. What I'm doing here, I'm subtracting 4 from both sides so that these two can cancel because opposite signs of the same value cancels out each other. So I'm going to be left with 4x is equals to, what is 16 minus 4 equals 12. I want to find the value of x, so divide both sides by 4. So I'm going to get x to be equals to 3. I'm getting x to be equals to 3. Sir, I didn't get that answer because I used the second equation. Okay. Let's just use the second equation and see what we get. 2x plus 6y equals 18. Anywhere in that second equation you see y, you're going to put 2. So y is equals to 2 right here. So I'm going to have 6x. I'm going to have 2x plus 6 times 2 equals 18. 2 times 6 is 12 equals 18. I'm subtracting 12 from both sides. It was cancelled. I'm going to have 2x is equals to 18 minus 12 is 6. Divide both sides by 2. X is equal to 3. So it doesn't matter which of the equations I use. I'll get the same x to be equal to 3. Now, when I put those two together, I'm going to get my critical point to be 3,2. Very important to write out what your critical point is. You do get a mark to tell them the critical point is 3,2. Don't make the examiners have to search for and to try and find the critical point. You're not going to get any mark for that. You have to write out and say, critical point is this. Remember, if the question carries anything, well, if the question is like 20 marks, 25 marks, 30 marks, don't shortcut the game. Because what you're shortcutting out of the stuff is you throwing away marks. If I only look at your answer, if I look at your answer and see your answer correct, but you don't have the working out, you can only get the mark for the answer. So any step that you leave out because you don't have time to write it, you're losing mark. So you may get the question very right and end up with 21 out of 30 because you did not show your working. So you have to be very careful with that. Let's go. So what it says, and it's a question on reasoning. So you have to reason with demand them. Demand them tell us the money is in $1 million. Let me show you. It says both of them, the X and the Y, are in millions of dollars. So when you get 3,2 and of 3, so. It is $3 million that was spent on labor and $2 million spent on automated equipment. So you're going to write out the stuff and incidentally, you're going to get marks for those. You're going to get marks for those. So you have to write out something, make the man them know so you understand what you're talking about. Now we need to classify those points. You see that something here? We need to know it here because we're not going to get it in the exam. So therefore, my AB right here, so, is now 3,2. 3,2. 3,2. 3,2. That's what it is. And I'm recalling here my C of XX, my C of YY, and my C of XY. All we do is substituting. So D of 3, 2, C of XX is 4. It is noteworthy that it is positive 4. It is noteworthy that it is positive 4. So why? Had it been negative, and we'll work it out and D is positive, it means that we're going to have a relative maximum. So far, if D works out to be positive, we're going to end up with a minimum. Why, sir? Because C of XX is positive. So 6, 4 is 24, and C of XY is 2, but we're squaring 2, so 2, 2 is 4. 24 minus 4 is going to be 20. So my D is positive 20, but my C of XX is positive, so therefore I'm going to have a relative minimum. That's why I get my relative minimum. And then the second part of the question, which is pretty easy, and then we end there, is simply saying to us, what is the minimum cost? Now you know what value minimizes production. Now you know what value minimizes production, which is 3,2. You now want to calculate what is the minimum value of the production of these television sets. So therefore, you're going to substitute your minimum value, your minimum critical points, into the original function, my C of X, Y. That's all we do. Substituting C of XY. And when you substitute in C of XY, you're going to end up with 12. But it's not just 12. It is $12 million. So how you know that? Remember the question says that both of them are in millions of dollars. Shamari, did you get 12 when I asked you to substitute it in the stuff?
Yes, sir.
Good. Chevy, did you get the $12 million right there?
Oh, should have done that.
Okay, so you're just seeing it.
Yeah.
That's the end of the question. A question like this is not 30 marks. A question like this is a 20 marker. A question like this is a 20 marker. So if they give you a question like this in the exam, best believe that they're going to give you another piece. But if you get this in the exam,
Sir?
to give that chance. Yes, please.
Yes, sir. To be honest, it's just a simultaneous part of
I know
but
that.
once we get that, we're supposed to go.
Mikey, I know that. And that's what is annoying me because you're supposed to know simultaneous equation long time. That's what is annoying me, Mikey, because you're supposed to know the simultaneous equation. So it is not the calculus 2 that is giving you a problem. It's the CXE maths that is giving you a problem. But remember now, if you don't know how to calculate, if you don't know how to calculate, if you don't know how to calculate, if you don't know how to calculate your simultaneous equation, you can't go further in the question. You see that?
Yes, sir, I see that.
Have you any questions? Any other questions? Any other questions?
No, not really, sir. It's just this document. Can you send it to us, please?
Not just this one. I'm going to try and find another past paper question and itch up on it. And I want to see who will turn up to class on Friday, God's willing, without the question done. And then I'll know that you don't want to pass the calculus 2. Are we okay now?
Yes, sir, definitely. Thanks
All
again.
right. Big up yourself. We'll talk, guys, next on Friday.
All right, sir, thanks.
Sir, remember the recording, please.
Okay, sir.
The recording has been uploaded, my dear.
Sir, I don't see it. I told you today that I didn't see it.
Anybody see the recording? No. Tajay said that he was watching the recording.
The one
Yeah.
from Monday's class?
I
The one for
don't
when?
know if it was
The one
more.
from Monday's class?
Today's Wednesday? Yeah, one for Monday's class. Yeah.
Then is one, oh, 1 hour ago. No,
But
2
is
hours
it
ago.
but is it there now? That's what I'm asking you.
Yes, it is.
Have a wonderful rest of the evening.
Sir,
You see,
before you leave, sir,
yes, Papa.
the mid-semester, when is it?
Let us talk about that over WhatsApp. We just need to agree on a time, because remember I said this week, I said to you next week, because this week you say you have programming homework and tests and something. Remember we had that? Oh, maybe you left, Mikey,
He wasn't here.
because you have to join another class. Yeah.
Yes, sir. Yes, sir.
Right. So we agreed that it's going to be one day next week, because other students have lots of assignments due this week and plus a mid-semester. So they said they're not seeing any assignments for next week or mid-semester, so we're going to meet one day next week.
Okay.
All right. Big up yourself.
All right, thanks.
No problem.